Okay. Thanks, Guru. Thanks, Akshay. Hi, everybody. Thanks for joining. And it is nice to see on a Saturday evening. People have taken time to join us. So, what are we going to do today? Let me start sharing my screen. Sorry that lighting of my room is not good for video. But next week I will fix the lighting and will try to show the face. It is okay if you don't see my face. It's not anyway not very beautiful. Okay. Do you see my screen?
Yes.
Okay. So today we are going to talk about the first session, and this is about the origin. Why we always have to go to the origin? That is one question I will start with. Before going further, I would like everyone to be feel free to interact and raise questions whenever they want to. And since this is a Saturday evening, we don't want to have a monotonous, um, some science discussions or some history discussions and all. It should be fun. Next time, next week, you should feel like you should want to come. Otherwise, it is not. Worth spending a nice time which we have for family in some session which is boring, right? So let us make it as interesting as possible. That is all, not just in my hand, it's the team's hands. Okay, so let us get started. um I will have a quick introduction of what we are going to do today. So in this course, as Guru has already mentioned, this is about to cover a basic introduction to everything, uh, about the whole from the beginning to the current times, and it may be very difficult to do everything in 9 or 10 sessions. So it will be very high level overview, and I have always discussed these sessions with my students in Community Computing Center. That was a different set of students. They were all kids from 8 to 12th, or even college going kids. But here the audience are completely different. We are all adults and we are working professionals. So 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 just to have a quick disclaimer is that I may be wrong in some places. Please correct me. And you may know better in some places, better than me. So if that is the case, you can take over the discussion and give us or enlighten us on that particular area. So we will cover the from the origin. We will go to the natural evolution process, and then we will see the how the natural evolution process that gave us the current physical form, right? So the natural our process of evolution gave us the current physical form. Then from that time to the current time, for example, the past 1 lakh years, right? If you take that, the social evolution has given us this cultural form where we are on top of the food chain in the earth, and then we have a great technology, scientific development, cultural development, etc. And this all given by our social evolution. And then how do we understand this? We understand this through major steps of inventions, discoveries that happened, that fueled the human progress, right? So I may be a biased person. Um, that is, as a science teacher, I see the whole social development, right? I see the whole human development, including social development or natural development, as a scientific process. People may have difference of opinions. So that is how I see it. So most of the most of the content of the course is going to be the 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 scientific developments, how the way we evolve in the process of scientific steps, right? After we get the physical form, and the social evolution is through our lot of inventions, discoveries, the way we look at the nature, all these things has happened, right? So this course is going to be in this direction. Okay. So where we will start, right? So we will go to the origins. Okay, before going further, do you expect anything else in this course? As I said, please feel free to communicate. So if you have any other things, anyway, we are going to create a WhatsApp. We can discuss there as well. Feel free to ask these questions there also. Okay. So where we start? So the whole human history, of course, cannot be understood without understanding Earth. Earth's history cannot be understood without understanding solar system, and the solar system without understanding the universe, right? So every body has to understand some idea, or have to have some idea about creation or origins, right? So if you ask someone, and normal people, where do we come from? Everyone has some stories. Every culture, in fact, has their own stories. So we will take up a couple of examples here. So Bible talks about Genesis. So God created world in 6 days, right? It was all dark before. So God created this world in 6 days, including human beings. On the last day, the God creates Adam, and from Adam's bone, from the navel, Eve is created, and we are all sons and daughters of Adam and Eve. And then God was tired and took rest on the 7th day, where our nice Sunday holiday is coming. Nicely, God took some rest, which is good for us, so that otherwise we would have been working for the whole 7 days in a week, or there may not be a week at all. So in Hindu mythology, there are a lot of creation stories. One, I took it from Manu, that Manu's Smriti. The world existed in darkness, according to this. So it was all dark. God dispelled the darkness, and God left the semen in the water, and it fell in fish's mouth, and their origins, born Brahma. Then Brahma started creating world. Everybody, every species, everything was created by Brahma, right? So that is a story, and I'm sure you might have come across several different creation stories, and several cultures. They have all their own stories. If you search through the net, a lot of such stories we can see. But we are concerned here about what science has to say, right? Science, when we talk about the story of science, creation, we cannot talk just in these few steps. So we have to start from the origin itself, right? So when we say origin, we will talk quickly about the timelines. So currently we are in 2024, right? This is the one I do always in the classroom, to just give a sense of how the years that we calculate now, right? 2024, where the 2024 number is coming from, right? So I have this origin of this number, or the years, from the Christ, right? That we all know. Before Christ, we call it we go in reverse direction, right? Before Christ, 1 BC, 2 BC, 3 BC and all, that all we know. So like that we have, and how long we go in the past, that we keep on going, and how long we go in the future, that we can keep on going, right? But then does this time has an origin? How long we can keep going? Does this time has an origin? Of course, there are some lot of such calculations has happened from the religious point of view also. People have given different numbers. At one time, Christianity predicted 16,000 years, or several calendars give different things. For example, Mayan cultures predicted like darkness is coming in 2012, something like that we keep hearing. But science talks about origin of universe, which came as part of the Big Bang. Right? So I'm directly talking about Big Bang. We will understand it, why Big Bang is so important, or how are we even saying that it happened, right? So, but let's start with that. Big Bang happened around 13 billion years ago. So that is when time and space formed. Okay, so the time that we are saying is started around 13 billion years before. Before that, what was it? We don't know. Science does not know. We don't know the idea of, we don't even know whether there was time existed. There was space existed, right?
This is Prasanna. Sorry to interrupt. Is it okay to put in presentation mode so that it comes to?
Oh, okay, okay. Sorry.
Thank
Yeah.
you. Thank you. Sorry.
Is it okay?
Yeah, perfectly. Thank you.
Thank you. So we have this 13 billion years of time, and so time and space formed. We keep going, right? And before that, we don't know when it all, what was it there before? Was there a space? All these things we don't know. Science does not know. And then it busted. Big Bang means it's a big burst, right? So it busted and it keeps going. So how do we know that? How do we even substantiate this Big Bang? When we observe universe, or just take a telescope and observe, or various ways of observation is going on. When they observe, they find that universe is expanding, right? So, and Edwin Hubble, one of the scientists of 20th century, found that universe is expanding, and it's not just universe. We have something called galaxies. Galaxy is nothing but collection of stars. Star is nothing but sun. As a sun is a typical star. It's nothing but a burning nuclear bomb, continuously burning bomb. We will come to that little later. But the universe is moving away from each other. All galaxies are moving away from each other. That is found out in very recently. And then they extrapolate this expansion to past. If it is expanding now, it was closer some 100 years before, it was closer further 1,000 years before. If we keep going back, this calculation led us to the point that that it was all together 13 billion years before, right? All together means all observable content that you see was all together in one point, as small as a proton in the atom. It was all together in that point. I should not call point. Point is something that is a debatable in scientific language, but it was all together in one single place at the size of at the size of a proton. So that is how it was close. So when it is so many things so close, so close to each other, we can imagine the density, right? If one person in the room itself, in my room now, right now, I'm sitting and we are two people sitting here. My wife is with me and I'm already sweating because it's hard. But if the same room will have 100%, what happens, right? And the same room has 1,000 people, then it's unimaginable, right? Matter was condensed like that um, in a size of a proton. So that is when that Big Bang happened. And then it started expanding and it keeps expanding. Okay. So who will stop the expansion? I don't know. We don't have any force which will stop the expansion, because something has to stop, or like if you all had gone through the Newton's first law during your college days or during your schools, everybody continues in its state, right? We will anyway come to these things later. So everybody continues in its states unless external force applied. So it started expanding. There is no external force. It keeps expanding and expanding and expanding. That is how we know that it was all together before Big Bang. So that is the most accepted theory from the scientific point of view. So the observable universe is around 93 billion light years in diameter. So which is very, very, very huge. I somewhere okay, yeah, it's very huge. That means we all know, just to give a sense of the size, light light travels at the speed of 3 lakh kilometers per second. And that if that light travels for 93 for 1 year, it will be around 9,000 trillion kilometers. So that is the size, that's the amount of distance light travels in 1 year. And the observable universe is 93 billion light years in diameter, which is like unimaginably huge, right? So that is the size of our observable universe. Why I keep saying observable universe? Because as we are going to see little later, there are a lot of things which we still do not know in this universe. So we are calling it dark matter, which will come to that. Okay, we'll come to that. So while universe has formed like this, and it's all dust, gas, and a lot of burning objects. It was very hot, and it started cooling down, and then slowly these gases got attracted and formed group of what to say, a gravitational system. So solar system is one such a gravitational system which was formed 4.6 billion years ago from gas and dust which are circulating, right? So so this the circulation and all, before going to the circulation and the solar system, I just got this expansion related discussion here. So as we discussed, Edwin demonstrated that there are multiple galaxies which are going away from each other, and on investigating Doppler effect. So what is a Doppler effect? Doppler effect is something that you can measure the wavelength, okay, that is coming from a moving object. If an object is stationary from one point to another, there are one moving object, sorry, there is a source of sound, let us say, and there is an observer. If they are stable, the sound will be, we will hear the sound normally, right? But if you are hearing a source of sound from a moving train, then you will hear it, hear it in a different pitch. I mean, a lot of things are changed. The sound itself will appear differently, right? As you see the train is crossing. So Doppler found that it is because of the observed wavelength change from the observer and the target. So don't worry about if you don't understand Doppler effect, we will talk about it later. But Doppler effect is something which is used to know that, okay, they observe the light and the infrared radiations and all coming from these moving galaxies. They say that, oh, okay, it is moving away from us. That is how they calculate the movement of universe or expanding universe, right? So okay, now it keeps expanding, and we know that there are gravity. We know that gravity is something that is pulling us. It's an attractive force. We all heard that gravity attracts. And we all know that there are matter which are not observed. But if that matter is opposite of the current matter, we all know that there are atoms consist of positron, electron, neutron, and all, right? If there are reverse electron, reverse positron, right? That theoretically it is not, we can't eliminate that. It is possible in theory, at least. And if that matter exercises anti-gravity, that is instead of attraction, it is a repulsive gravity. If that is acting, which is making the universe expand, then nobody is going to stop it, keep on expanding. But then, instead of that, if this universe expands and at some point of time gravity take over, the positive gravity that feel nowadays, universe may come closer, and it all can collapse into one single object, and then it may expand further. Sorry, it may again collapse, and another Big Bang may happen. So that is something that we don't know, right? For now, we don't know. Just to understand, so this is how the universe keeps expanding. It is like if you take a balloon, put some dots in the balloon and blow it, it will keep expanding in all directions, right? So it's like that universe is expanding in all directions. And from wherever you see, you will look like you are in the center of the universe, because in every direction it will look the same. In every direction, till whichever point you observe, you will see that, okay, there is no end. It keeps going on like this. So for all purposes, we can still think that we are at the center of the universe. But anyway, we are not at the center of even the solar system. We'll come to that later. Okay. So, any questions so far?
Only one interesting observation in your last picture. If you see up to 10 billion years, it's like a straight line. Straight line is.
Yeah.
Then after that, it has started curving.
Okay.
So that's geometrically, it is like having a constant rate of expansion. And the constant rate changes, which means it's no longer a constant expansion, but either faster or slower, either accelerating or decelerating. In this case, I think it looks like accelerating, which is quite beautiful.
Okay. That could be because of dark energy make anti-gravity more, right? We don't
usually,
know.
right, because usually, as you mentioned in Newton's law, when we apply a force, something accelerates, but that force should always be there to accelerate for any body.
Yeah.
So initially, after Big Bang, I think the force had not existed, so it was not accelerating; it was going in a constant velocity. And when dark energy crept in, once again, there was some accelerating force which is causing the acceleration, possibly. So just could relate those. It's a nice example. Thank you.
Excellent. Thank you. Okay. Any other question? Okay. So just to give some facts related to solar system. So it all formed around 4.6 billion years ago. It's a gravitational system. So as I told in this course, we will all this information all are available in the net, right? Or different books. What are we doing here? We can all go to these details in books and all, but what are we doing here is collectively we want to develop some perspective, right? So we want to have a sense of appreciation. Just going through one set of way of thinking, we may be associated with. Now we want to see if we have another way of thinking, especially in a very at least little scientific way. That is what we are trying to build, right? So why I am giving this is that how insignificant we are when we see the way the universe works, right? How insignificant and how little we are, and then we want to, if you don't appreciate this, then it is something that we are missing in the life, right? So that's why I want to give some exciting informations, or the information that changed my perspectives about myself and the way I look at others, or the universe or nature. That's what I am sharing with you too. Okay. So this in the solar system is I initially thought from my childhood, why this planet keeps going around? Will there any way how it is fueled even to go around the solar system, right? Even to move a bike from one place to another, we need to put some petrol and move, right? So who is fueling and how is it going around? So that kind of questions is always there in from my childhood and with a lot of people's mind. Right? So what changed the perspective is that the way it is formed, right? The solar system, the way it is formed, is a gravitational system itself. From the birth, rotational movement is part of the solar system, right? If there is no rotational movement, the solar system would itself probably would have collapsed. All the Earth, planets, everything would have collapsed in the sun. So that's why it's called a gravitational system and formed around 4.6 billion years. Of course, with all the materials, dust, particles, everything which came out of this Big Bang. So, and then some of these dust are formed in some group and make some planets. A planet is we can think of as a satellite, which is always coming around the solar sun. And then these planets are different sizes and shapes. So Mercury, Venus, Earth, and Mars, they are the very, very, terrestrial planets, right? Terrestrial planet meaning you can go stand there, you can feel that sand, dust, or rocks, or whatever it is there in the planet. So they are all terrestrial planet. Jupiter and Saturn are just gas giants. So that means you can't go and land there. And Uranus and Neptune are something that it's like a lot of ice there. So if you see here, the the only thing that we have for us to live, appreciate our life and all is the place here, because Mercury, Venus is very hot. You can't even go there. And Mars is very cold and no water, or water is there or not. Scientists are debating. So let them come to a conclusion. But now, we don't know whether life is possible there. So Earth is the only place we have, and that's where we are. Unfortunately, we are very lonely, and we don't know whether life exists outside the solar system. So if you see the solar system, sun is the nearest star. Sun is nothing but a type of star, a typical star, and that the sun keeps burning for 4.6 billion years, and it will keep burning for another 5 billion years. That's the amount of fuel it has. And then it is there. It's there for so long, and we keep coming around the sun, and we are in Earth, and that's the only planet has life, right? So if you see here, this is just to give a perspective. Sun is, as I saw in the previous slide, Sun has the 99% of the mass that is there in the solar system. All other planets together is just 1%. So in that one, just to give a perspective, you see the Earth is very, very small when we compare to size. And other planets are relatively better, bigger, but then they are not terrestrial planets. They're just gas and ice giants and all. So insignificant, right? So that is how it is. So when we see this system, so the question of how we keep rotating, right? There are always two forces. So so how do we say that? So Earth is always moving. When it moves, we all said that we all know that if something moves in a straight line, it will keep moving in straight line. That's what Newton's first law says. Unless you give an external force, you can't change the direction. Only with an external force, we will change the direction. So with the Earth, if it keeps moving straight line, then we have a sun somewhere which is very, very huge and very dense, and there is a gravity which attracts the Earth. So the gravity pulls the Earth, and the Earth wants to move it in a straight line. So this both forces keeps balancing. That's why it keeps rotating. So that's an excellent system that keeps us moving across around the sun, right? So Earth is started forming around 4.5 billion years ago by a process we call it as accretion. It is nothing but several dust, clouds, rocks, and all came together to form, to continuously bombard in some center point because of gravity, and it formed a massive object, right? While it is forming, there was a big Mars-sized object hit the Earth and formed the Moon. Moon is the Earth and the Moon is like a twins. Okay, it keeps I mean, for all purpose we say that Moon is rotating the Earth, right? Moon is our natural satellite. A satellite is something which is nothing but a smaller objects rotate the larger object. So, but this, from the Moon's point of view, if you see, Earth is rotating the Moon. So it all depends on from where you are observing. But Moon is our only satellite, that is only cousin that we have nearby, or only sister or sibling nearby. So, and then Earth kept cooling. After some accretion complete, it kept cooling, and lot of gas around the Earth formed atmosphere. And then water got formed because of the various this hydrogen and oxygen molecules come nearby, and it poured into the Earth for millions of years and burned that sea and other things, right? So that is how that that's how the Earth formed. So when Earth is formed, we all think that, okay, we may be asking the question like, oh, okay, when is life is forming, right? We will come to that little later, but still, just to give a quick overview, Earth and life, we cannot think as two different things. Okay, when Earth formed, life formed. That's how, as I read more and more, I thought these two different process, but as I read more and more, Earth's and life's history, we cannot separate we cannot separate it out. It is together. Okay, we'll come to that. So Earth, if you see that, okay, Earth formed, and then if you see that only place, again, I'm coming back to that, the way we want to appreciate our existence, right? If you see here, the Earth's atmosphere, right, above our head, you see we have only around maximum around 20 kilometers, right? Around 20 kilometers, if you see, you have this troposphere still 20 kilometers or 18 kilometers, where we have everything. Our birds fly there, our planes go probably in that layer only. And then we have mountains. Everest is even lesser than this. So this atmosphere that we have our life, especially, is within these 20 kilometers. Beyond that, it is oxygen pressure becomes less. You may not be able to breathe. You need additional equipments to go above, right? Similarly, if you go down deep, this in the right side of the figure, if you see, again another not more than 20 kilometers, where the sea's depth, if you keep going down, you will feel pressure, and if you keep going down and down and down, your lungs itself will collapse because of the pressure. It will not be able to breathe. Of course, there may be other animals or species which is able to sustain life there. But whatever it is, it may not be more than 20-25 kilometers down. After that, it is maybe very, very small biological. I recently read some articles about some bacteria living in very hot environment under the earth. But apart from that, the visible life that we see is less than 20-25 kilometers depth, not more than that. So we have only earth for ourselves. Even in the earth, from the surface of the earth, 20 kilometers above, 20 kilometers below, that's all we have to have our life. So that is what gives us life. It's beautiful. So yeah, before going further, we also have to talk about that we just said that there are a lot of burning happening in the sun. Sun gives a lot of energy, light and sound, actually. Heat, light, sound. Thankfully, sound does not travel when there is no medium. Of course, I mean, in between sun and earth, we have a lot of space which does not have air molecules to vibrate. So we do not hear that sound, right? We have only light and heat comes from the sun. So when we get some heat and light, there's something that has to burn, right? Only when something burns, we get heat. So what is burning there? We all know that it is hydrogen or helium. Sorry, hydrogen is converted to helium through this process of fusion. Fusion and fission, we will come little later. But fusion is nothing but when two nuclears in a atomic process, if nucleuses join and radiate energy, it's fusion. When nuclear bombards and radiates energy, it is fission. Just let us have it at a very high level for now. We will talk about this little more later. So, but here in only fusion, as far as we know, is happening in sun, and that too in hydrogen atom is converting it into helium. Okay, so because of that, it releases some in this process, it releases a lot of energy. It's nothing but continuous millions of nuclear bombs burning there. Okay. And then, okay, if this fusion goes on burning like this, what will happen after some time? Then the fuel gets complete, I mean, all burnt out. We will see that this gets coming closer and closer. As we all know that when there is a huge mass, there's huge gravity there. So if currently the sun is burning because there is a lot of hydrogen atom, it bursts and goes out, but there is a lot of gravity because of its mass, it's pulling it inside. That's why it is like a ball continuously blowing. But if one of these forces does not balance, if gravity becomes less, the burnt fuel will get out like a big bang. It will, all the material will go away. But if the gravity takes over because of not enough burning happening, not enough bursting happening, then it will fall inside, right? Like that, if the helium, all hydrogen is converted to helium and there's no more fuel, the star, our sun may collapse. And when it collapses, there is one possibility. There are multiple ways death of a star happens. It's all there in science. But one thing that always fascinates people's mind is that some sun can collapse itself into a black hole, meaning the whole gravity, everything, if the gravity becomes huge, all matter will go into that sun, including earth, everything. As it gets more and more matter, it becomes more and more heavy gravity, and then that will attract everything, including light. So that means we cannot see where that black hole is. That's why it's called black hole. Of course, there are a lot of things that continuous researchers are going on in black hole. They say that some radiations coming out from black hole. All these things are there, which we can take it up later, or I will ask you to read. But we know that there is a continuous process in this whole universe. It's not static. That's what we want to tell here, right? We want to understand that the universe is not static. When we go and look at the earth, when the sky in a night, it all appears calm and silent and nice, right? But it is not like that. It is continuously moving, continuously bursting, evolving, dying. All these are there. Only thing is, it's a very large scale, and humans in our lifetime, it is very difficult to find, understand, and appreciate. Right? So what will happen to the solar system in future? Okay, as I said, gravity may take over, universe can come back together and collapse, and then it may burst again. That's called cyclic universe. Our scientists say that it keep happening. This continuous Big Bang will keep happening. It's a cyclic universe. We don't know. It may happen in another 13, 14, 15 billion years later. Similarly, there are another theory talks about that there is always evolving universe. Lot of bursts are happening simultaneously, and then one of the universe actually becomes fit for evolution of this to become like the universe that we see now. All these things are theory. We don't know yet, but for now, at least for our sun, we still have fuel for another 5 billion years. But the rate at which we are farming the pollution in the air, we may not last for another 1,000 years. So we don't know, right? So universe is going to exist, and it's going to be there way long. So we don't have to worry about its future. So that takes us to the next logical point, the life. So before going further, any question, any discussion, anything you want to add, or any mistakes you want to point out? I said, please make it more interactive. Otherwise, it will be boring. I can keep talking, but it's better we make it interactive. Okay.
Just one question.
Uh-huh.
This is Prasanna.
Hi,
You are
Prasanna.
mentioning about two possible schools of thought. One is universe expanding, and then universe is collapse. So, what is the present thought which dominates based on available data? Any evolving universe or uh,
No,
cyclic universe?
currently it is still the expanding universe, right?
Okay, okay, okay.
It
No,
is
no,
continuously
then
expanding only, but now.
okay. Then wondering what prompted the cyclic universe thought process.
They're trying to say what will happen in future. Will it keep
Okay,
expanding? At one point of time, gravity may take over.
okay, okay,
And then when it gravity takes over, it will start attracting every object, right?
okay,
So when it attracts, it may again come back. Everything can come close and come collapse into one single point. Again, it may burst
okay,
because density will be very high
uh,
when the gravity goes up. So it
okay,
may again expand. So that's what is called cyclic universe.
okay, okay. Yeah, thank you. Thank you.
Okay. So as we discussed, we cannot separate Earth from life. Life itself is 4 billion years. They estimated like life in Earth is there for more than 4 billion years. That means we just saw in previous couple of slides before, we saw that it was 4.3 billion years or 4.6 billion years sun has formed. Solar system has formed. So Earth and solar system formed almost together, and then life also formed almost together. So where the life come from? There are multiple theories, but there is one. I mean, not multi. As I said, we just saw that sometime back. There are multiple cultural, what to say, stories, right? How God created different people in and various things. But then, when it comes to life, somewhere we are looking for, when we look for the origination of life, we say that life started somehow in the earth, which we'll talk a little later, somehow in the earth, and it evolved, right? So originated in earth itself, there seems to be a question. All these life's basic components, like for example, if you take that fundamentals of cells and all, if we take it, we will see life is made of, I mean, our cells are with basic fundamental components, amino acids, proteins, sugar molecules, all these components that are available, these components like amino acids and all, based on ammonia gas and hydrogen, all this is available in space also. So there is a theory that life originated in space in the form of spores. Of course, not as we know, in the form of spores. Spores is nothing but some biological self-replicating molecule, content of the self-replicating molecule. We continuously receive this kind of molecules in Earth, even now, right? Why not in the beginning, this kind of space molecules, which is like a self-replicating structure, comes to Earth, and in the Earth there was a conducive environment to spread, right? I don't know. There are all different theories available. So somehow either it is originated in space or it originated in Earth. We have Earth was in such a place where life can evolve. So it was in a conducive environment with the various like water and other atmosphere. Of course, there was no oxygen then. When life started, there was no oxygen. And then And that is how it would have come from space or Earth. But then there was a conducive form in the Earth which triggered the life. Okay, so there was one in 1953, just to suggest how you could have evolved. This Miller-Urey experiment. You can talk about read about this in the net, but the spirit of this experiment is nothing but what could have triggered in Earth the life form in Earth. So what they did was they did this put this H2O, that is water, methane, and ammonia gas inside a chamber and pass the electric spark. In nature it would be lightning and all. They pass these electric sparks to see that the amino acid and fatty acids getting formed in 2-3 days. After this experiment conducted, they saw that amino acid nothing but your proteins building block. So that is how life could have formed. That's an experiment, a very famous experiment that we can see in the net. So with that, let us say, so science accepts this as an origin of life has happened in Earth, and it has happened only once. Okay, so what is life then? It is a self-replicating molecule should be there, and it should consume food, reproduce, and then from single cellular to multicellular, it keeps evolving, and it becomes a better, bigger and bigger life form, and that's how life formed and evolved. We will see the life's process in detail when we go through the evolution theory. But for now, we will be at a very high level. So the single cellular organisms, self-copying molecules. So always keep that in mind. Self-copying molecules is the basic content of life, right? Because all other things can say if you take any other body, it may consume energy, it may move, it may even think intelligently. Nowadays the computers are there, but when you say life, it should reproduce, and it should self-replicate, right? So that is what life is all about. And then it continuously evolved, and over millions of years it became different species. And then at one point, plant kingdom have evolved. Once the plant kingdom has evolved, it took carbon dioxide and bring back a lot of oxygen in the earth. That gave a environment for other oxygen consuming animals like us evolve, right? So that is evolution of life. Okay, so let us quickly go through that one. I want to introduce one website.
Just one philosophical observation.
Mm.
Just like you mentioned, when Earth started forming, life also started forming.
Mm.
And inherently, when life started forming, its death also started forming, isn't it?
Of
Else, it will be
course.
an accelerating, just evolution and replicating. But then, death is also pre-programmed in the evolution.
Okay.
Mathematically, what sense or physical sense it makes? Just wondering, because in the previous thing you mentioned, universe can collapse also. It is
Yes. Yes.
analogy is close to the life. That's what.
Yeah. Yeah. Definitely. Definitely. Yeah. Of course, when we say life, there is always death is associated with it, right?
Uh, True.
Definitely.
So, can that be expanded in a way to the universe philosophy also?
I don't understand.
You were mentioning that universe is expanding.
Right.
It is like a life expansion,
Okay.
and then we are also thinking about it will collapse and it will.
Oh, okay. So you are asking about how life will collapse itself in Earth.
Yeah. We see that life is collapsing.
Hmm.
Of course, that could have prompted maybe the universe model
Oh, okay, okay.
where we expect universe to also to, because with the existing, as you mentioned, with the existing data, we can only say that life will expand.
Yes.
So that looks like an interesting.
Existing data, we know that life is evolving.
Right.
Yes, continuous evolution is going on. We do
Mhm.
not know whether that the evolution itself will expand. Life keeps adapting because um, as we are going to see soon, Darwin's evolution theory talks about how each species adapts to its environment, right? So of course, if it is all possible till the existence of Earth as it in its current form, right? We do not know what could be the form of life if Earth doesn't exist.
Okay.
Right?
Yeah.
So that is unimaginable for us still.
Uh,
Uh,
yeah.
in existing Earth itself, life may collapse over a period of time. At least human species may collapse. So we are going to talk about it. There is a book called Collapse by Jared Diamond. How societies collapse. We have seen Mayan civilization died. Indus Valley civilization died. A lot of this civilization died. That all this civilization had one kind of this book talks about one kind of property which because of which they all vanished. Where, for example, when in Easter Island, there's something called Easter Island in Pacific Ocean, very small island where people were there and that collapses, that civilization is not there anymore. It's very lonely and they don't have communication with others. They don't have various transportation of food. When they're unable to generate internally, they don't have ways to transport food because they're very far away from other lands. So, and then they had to consume their own, resources fully finished, and then they couldn't consume anymore. They collapsed. If you extrapolate this idea to our Earth, are we not very lonely? We are very lone. We don't
Yeah.
have any other place nearby to communicate. We can't borrow some food from Mars if we don't have food, right? So this guy, Jade Diamond, thinks that okay, all these theory that I have seen or are these properties of this collapsing society, if I apply to Earth, it is same. That all these properties exist for Earth also. So life in Earth, as we know, this form may also collapse. And human beings definitely may collapse very soon. We will talk about that later.
Yeah.
Yeah.
Sure. Yeah. Thank you.
So this one is a nice website. I found it from one book. So if you see here, they give a nice uh, a tree of various origins of species. So you can go back and forth. Okay, I don't know why. So you can go, if you want to check particular this thing, you can go here and check. Very nice way of they show. Hold on. I don't know why it is not responding to my mouse movement. Give me a second. Let me try in another browser. So I don't know why when I'm trying to shrink it, somehow it's not shrinking. Okay. Yeah, okay. Here it is. Okay. Isn't it beautiful? See, if you see, I want to go back, this many millions of years ago, this million years ago, this million years ago, how many species? All this, we can keep reading about it. So that's something that I will put it in the slide and upload. You can check that. Okay. So this is about this. This book. Right. So there's a nice book on evolution. I took this nice website from this book and it was referred there. And for this session, I tried to get content from these books. If you want to verify or want to read further. So that is where I want to stop and want to take some questions if you have. Only one person is talking, nobody else is asking. Any question?
Yeah, this Ashwin here.
Hi.
One question. You are saying na, without oxygen there were some kind of life forms used to exist. What without oxygen I couldn't imagine there is something could exist. What kind of form existed without oxygen?
There are a lot of non-oxygen breathing bacterias and
Like
other.
like this kind of cellular, right? Bacteria which is
Yes,
not observable through eyes.
yes. There are
And you also
microorganisms which does not need
okay,
oxygen.
okay.
Yeah.
And you said like spores. There are two theories.
Mm.
We either the forms created from space or in the life on Earth directly. So you
Right.
said some spores are keep on coming
Yeah.
from the space. So you
Yeah.
are saying until today it is coming,
Yes.
which means you are saying new forms or new things is getting evolved every day that we are passing in.
Maybe. Yeah. We keep still inventing new species, right? Maybe.
New kind of form, new forms
Yes.
or completely new things. Okay.
It may be farming. We may not even know because of evolution. It may not be fit for the others already formed. There are other lives already formed.
So these spores that is coming from top, it will
Mm.
mostly get attracted to its gravitational force, right? Or any possibility they will lie in some kind of atmosphere or some case.
No, it may be still coming to Earth. Some may be getting filtered, some may be able to penetrate the atmosphere and may be coming inside. But it may not be conducive enough for it to make a new farm now. It existed
Okay.
like
Okay.
4.6 billion years before, right? That
Okay.
means, yeah, that spores are not life itself. It is a life organic components we're talking about. That component may not become life now.
Or
But
there
it,
may not be a chance. Okay.
yeah,
Okay.
that may not be a chance. Yeah.
Okay.
And remember, there is a continuous evaluation still going on.
Hmm.
Yeah, we will talk about it. There is a question, nice question. One of my brilliant student asked. Sorry, you said we came from monkey, right?
Yes.
Monkey trans. I was talking about this evolution, and there's a famous this thing, right? There's a famous picture. You see that one monkey walking in 3 or 4 legs, and then it came straight up, and then there's one picture there. Very famous picture we'd have seen. So
Yeah. Yeah.
that kid is asking right now. Sir, you said it coming from monkey. Why monkey still exist?
Hmm.
That's a nice.
It's a continuous evolution, like you said.
Right.
We got evolved.
There's one kind of ape we became humans, but other form of apes are still there.
Still existing. Yes.
Existing, right? Other form of apes and monkeys, primates, they still exist.
Yeah.
So that was the discussion. It was nice discussion. So what I'm saying, what I'm trying to say is, we are continuously evolving. We
Yeah.
ourselves are evolving.
Even our size is reduced or increased, something like that. It used to be very large
Yeah.
comparatively. Now gigantic like that. Maybe we reduced over the years, over the many years, billion years.
Exactly. I read one more very fascinating article. What they say is, see, we were all very physically working so far.
Hmm.
Now only we are into very sedentary lifestyle, right? We are now sitting most of the time working and all. Going forward, because of this evolution requirement, our brains will become more and more evolved and our head will become big.
Okay. Okay.
Our body will become smaller and smaller. That is how, I don't know how we will look like if our head is
I
disproportionate.
feel it is a alien. I assume
I,
alien used to be like that. Okay.
yeah.
Maybe
So
because of these theories only.
yeah. So because we have more now, we are more and more brain related work we are doing, not physical work. So
Yeah.
whenever we don't use certain things, it goes away. So
Okay.
that's
Okay.
something. I mean, it's a nice article. We will talk about those things when we come to evolution. Yeah. Thanks. Any other
Sure.
question?
Thank you. Yeah, that's it. That's all. Thank you. Thank you.
Any other question from anybody?
I mean, for the example you gave, I think even Gangaru is a good example. You can see its four legs looks
Uh-huh.
not stronger as the hind legs. Because
Right.
hind
Right.
for the jumping and all those physical activities.
Yeah.
So, so
Exactly.
what you
Yeah.
said can be the can be the pathway of our physical shapes also based
Yeah.
on the work style.
Excellent. Yeah. Okay. If there are no further questions, I will upload these slides into this course, into the Moodle platform, and we will try to get this recording also upload to this platform, right, Guru and Akshay?
Yes, you're right. We'll do that.
Oh, okay, and then we can refer it at any time and discuss on it. Other than that, I'm done for today.
So, Bala, you can also give an outline about the next modules, how the course will evolve. What are the things we're going to cover in the entire course?
Okay, so so now that for now we will, from this first session, we will slightly go into the social development. That means see, evolution gave us this shape. After that, what will happen? The cultural things take over, right? So we formed societies, we formed civilizations, we formed education system, we formed history, all these things. So little bit of cultural evolution. Then we again come back to the recent scientific development. So cultural evolution 1 or social development 1, social development 2. Those are 2 sessions we are planning. Then scientific development 1, 2, 3, 4, 5, 6 or whatever. And in between also we can swap between social and science development in whenever we need it. That's the plan. So we try to take till the information age, till the current information age and AI and what is going to happen. Especially we have this guy, right? Our Noah Harari, the author of Sapiens, is going wild, opposing this AI. Talks about how it's going to be a problem in near future. Till that, we will try to talk. So AI and its ups and downs. Yeah. So that's the plan. So mostly the origin to the latest development will be in the steps of scientific improvements. That's how you can think of this. You can think of this course. Is that okay, Guru?
Yeah. So, I mean, the way we'll check with everybody. When it's 6:30 Saturday evening, is it okay with everybody? And when we have more people registered, I think for maybe communication through email is not reaching everybody. So we'll
Right.
Akshay is forming the WhatsApp group, reach out to all the joinees. So we'll reach out to them, and probably we'll have better attendance next week. I think next week onwards. So it's the.
Do we have to repeat this?
No, we don't repeat that. What we can do the recap, the next section beginning, and anyway recorded video will be kept in the LMS that can be used.
Okay.
And you can also share any of the reading materials in the same.
Reading material there in the last slide, Guru.
Okay. Okay. No, in the if there is a reading material which can be uploaded to the LMS, we can upload them.
Oh, okay. Okay.
Module wise, week wise, we can upload them.
Okay. Okay. Anything else anybody wants it to be covered in this course? Okay, then. See you next session. Thank you.
Okay, next week 6:30 we'll meet up again.
Okay.
Thanks everybody. Thanks Balaji.
Thank you.
Thanks Akshay.
Thank you.